In this video tutorial, we will tackle 3 topics, and those topics are Introduction to Functions, Quadratic Functions, and Conic sections. A function is a rule of a relation between an input quantity and an output quantity in which each input value uniquely determines one output value. There are few basic elements present in a function. One is domain, which is the set of inputs which serves as an entry value to the function rule. Another is the range, which is the set of possible outputs.
There are plenty of ways on how to map a function. One is through the ellipse or the arrow diagram, wherein you list the domain and the range inside an ellipse, and then connect it using an arrow. How can we identify if an equation is a function or not? Simple. Always remember that 2 or more outputs can't have the same input, but 2 or more input can have the same output.
Quadratic function is a function with standard form of f of x is equal to ax squared plus bx plus c, wherein a is not equal to 0. When solving a quadratic function, you must first create a table of values so that you can plot the points and draw the graph. A good technique is to first find the direction to where the quadratic function is going. From the equation, when a is greater than 0, then the graph is going up. But if it is less than 0, then the graph is going down. After that, you have find the vertex of the quadratic function, which is the highest or lowest point of the function's graph, depending on the direction it is going. Then you will base your table of values on your vertex. One example is the function f of x is equal to 2x squared minus 4x plus 4. From the equation, the graph is going up. Since the equation of the vertex is negative b over 2a, so from the equation, we know that the value of b is negative 4. And then the value of a is 2. So substituting to the vertex equation, we would get 1. Therefore, our domain is x equals to 1. Substituting to the function rule, that will give us 2. Therefore, our vertex is located at point 1, 2. We know the vertex, we could just include 2 numbers lower and higher from the vertex x coordinate. Therefore, our x values are negative 1, 0, 1, 2, and 3. By substituting these values, we could get our y values. Y values are positive 10, 4, 2, 4, and 10 respectively. So the x values are our domain and the y values are our range. Since quadratic values has a lowest or highest point, which is the vertex, in this case, it is the lowest point since our vertex is going up. Therefore, our domain is all real numbers and our range is all positive values greater than 2 since it is the y value of the vertex.
To conic section. A figure formed by the intersection of a plane and a right circular cone. Depending on the angle of the plane with respect to the cone, a conic section may be a circle, an ellipse, a parabola, or a hyperbola. A double-napped circular cone is the shape formed when 2 congruent cones put on top of each other, their tips touching and their axes aligned, with each are extending indefinitely away from their tips. The double-napped circular cone has 6 parts. The central axis, which is the vertical line down the middle of a double-napped cone. Also, it is the line that remains at fixed. The generators, these are the diagonal sides of the double-napped cone. Also, it is the line that rotates about the fixed point. The vertex, which is the point at the center of a double nap cone, also it is a fixed point. The upper and lower nap, which are the lateral surfaces of the double right circular cone. The vertex angle, it is the angle between the central axis and the generator. It is denoted by A. When a plane perpendicular to the central axis passes through one nap only, perpendicular to the central axis, a circle is produced. When a plane passes through one nap only and the angle made by the plane and central axis is greater than the vertex angle, the conic section that is produced is ellipse. A parabola is produced when the plane passes through one nap parallel to the generator. A hyperbola is produced when the plane passes through both naps between the central axis and the generator, and the angle made by the plane and the central axis is less than the vertex angle. When the plane passes through the vertex, a circle and an ellipse will degenerate into a point. A parabola will degenerate into a line. A hyperbola will degenerate into two intersecting lines. Equations of the conic sections can be expressed through the second degree equation of the form ax squared plus bxy plus cy squared plus dx plus ey plus f equals to 0, which is determined by the values of b squared minus 4 multiplied by a multiplied by c, or 4ac. Why do we use the discriminant? Because in a quadratic equation, the discriminant helps tell you the number of real solutions to a quadratic equation. The expression used to find the discriminant is the expression located under the radical in the quadratic formula. So, the equation forms a circle when the discriminant is less than 0, b is equal to 0, or a is equal to c, and the value of eccentricity is 0. Meanwhile, the equation forms a parabola when the discriminant is equal to 0 and the eccentricity is equals to 1. The equation then forms an ellipse when the discriminant is less than 0 and b is equal to 0, the same as a circle, but a is not equal to c and its eccentricity is greater than 0 but less than 1. Lastly, the equation then forms a hyperbola when the discriminant is greater than 0 and its eccentricity is greater than 1.